Thank you very much for this next for coming to this next talk in the Using Docker for Developers track. We are going to be talking about patterns for success in application transformations. Elton Stoneman does not need an introduction, I think. You saw him rescue the pet store pet shop app, I think, in the general session today. And we're going to see more of that. I think it's going to be a pretty good deep dive into how to rescue your old apps and bring them forward into containers. Elton, as I said, needs no introduction, lives in England, and apparently running away from the bustle of the big city. He's headed into the countryside these days. I was also happy to hear he loves cricket, at least his family watches cricket, and between him supporting England and me an India fan, I think we'll probably have quite a few good conversations in the future. But until that happens, let's get started.
Thank you very much. Okay, so good afternoon. My name's Elton. I work for Docker. Thank you for joining me. So this session, I apologize, it's got the worst title of any session in the whole conference, so thank you for coming. It is actually a good session. So what I'm going to talk about is how you can take your legacy applications, your Java applications, your .NET applications, move them to Docker and make them behave like new applications. So make them fit inside the world of your container platform so they behave just like a modern microservices app without doing a full-on 2-year rewrite. It's quite a lot of content, there's a lot to learn, but everything I'm going to do is up on GitHub, and all the demos I've got a Java demo and a .NET demo for everything, and all that stuff's on GitHub. So if you want to, you can follow along with it afterwards. So there's quite a lot to do, but before I start, I've got a favor to ask. So today is the 4th of December, which means it is my little girl's birthday. And she is 1 year old today. Now, I'm not there to say happy birthday to her because I'm teaching you all about application transformation patterns. So if you will indulge me just for a moment, I'd like to ask you all to sing happy birthday with me. So now, don't worry if you can't sing. It's not about tunefulness, it's about volume. And if you're not confident in singing, that's fine. But if enough people don't sing, I am not going to do the rest of the session, okay? So let's switch this on here. So you can't see, but I can. I've got a Zoom session here. This is my little girl. So we're going to do it on tres, okay? Uno, dos, tres. Happy birthday to you. Happy birthday to you. Happy birthday, dear Eris. Happy birthday to you. Hey! Okay, I'm going now. And do you know what? I forgot to press record. Oh, well, not to worry. Okay, cool. So now on to the session. Okay, containers. When you run your application in a container, all your applications look the same. Thank you for that, by the way. I appreciate that very much. They all look the same. Doesn't matter what's inside the container. Doesn't matter if it's a brand new Go application running on a tiny Alpine Linux image, or whether it's a big old .NET application running in a 15 gigabyte Windows image. The container platform treats them all in the same way. Whether it's Kubernetes or Swarm or whatever orchestrator comes in the future, the containers are all going to look the same. That's one of the key things about running your apps in containers. And what the container platform actually does, if you think about it in a kind of logical way, is when you start a container, it kind of creates this space, and it puts your application in that space. And so think about it as a kind of puzzle piece. Each of those connections are integrations between your application and the container platform. And so for a modern application like Node.js, it fits really nicely in there. It fills out the whole of the space. The way that a Node.js or a Go or a .NET Core application is kind of meant to run fits very nicely with how container platforms expect to work with containers. So things like it starts in the foreground. It's a single process that runs in the foreground. It's easy to get logs out from standard out. Things like that. Now your legacy applications, you can run them in containers, but they don't fill out the space. They don't run in the way that your container orchestrator expects them to run. So you can't get that easy integration. And that's what this session's all about. So the 5 points I'm going to talk about, and these are the 5 patterns from the bad title. The 5 points are about your integration points between your application in your container and the container platform. So firstly, logs. Getting logs out from your application. It's boring, but you have to do this stuff because your application is probably writing reams and reams of logs, and you need to get that out into your container platform. So Docker has this plugin mechanism for logs. So as long as I'm getting logs out from my container, I could be shipping them off to Splunk or Elasticsearch or whatever my plugin I'm using. Second one is configuration. So one of the key things about running apps in containers is I have the same image everywhere. So the same image that I built from my CI system that's passed all my integrated tests is the same image that I'm running in my user acceptance testing. It's the same image that's been signed off and is running in production. The exact same set of binaries. So I need to be able to configure the container at runtime in different environments, but make sure I'm using the same image. The third one is dependencies, so making sure when the application starts, it's got everything it needs. It can access all the dependent services that it uses. And if it can't get those things, that it behaves in a way that the platform understands. The fourth one is health, so that's the kind of reverse, so feeding back to the platform and telling it if the application in the container is healthy. And the last one is metrics. So typically, starting on your Docker journey is actually pretty easy, even for old apps. It's pretty easy to write a Docker file, get your app running in a container, and then write a compose file, get the other bits running in containers. But before you go live, and when you're running it on your laptop and you're running a single container for everything, it's pretty straightforward. You can do your tests, you're happy with it. But when you go live and you're going to be running across 50 containers for your website and 30 containers for your API, you need to know that you can get the information out to see how hard those containers are working and what's going on inside. And that's what the metrics come in. So quite a lot to do. So what we're going to do by the end of this session is we are going to fill out those integration points. We're going to make our old legacy application touch all the points that the container platform works with so they behave and work just like modern applications. Okay, there are three things that are core to this, and some of this stuff is opinionated. So firstly, I think it's really important that you can achieve this without changing code. So I know this is the developer's track, and we are going to see some code, but it's really important to be able to say, we can take this legacy application that's running on Windows Server 2003. I won't ask for a show of hands, but I know some of you are running Windows Server 2003. The team who built that application, they're gone. Like, they've retired, and they're all doing something else. The source code's gone. There's a zip file somewhere with some source code in it, but that might not be what's running. You need to be able to know for sure that I can take that thing and put it in a container and fill those integration points and run it in the same way as my modern applications. So you need to be able to be sure you can do this without changing code. You need to be able to do it without taking a specific technology dependency. So the patterns I'm going to show you in a way that you can run them in Cube or Swarm. Some of the patterns are much easier in Cube, because Cube lets you have this notion of two containers that live in the same sort of space, which Swarm and the other orchestrators don't have. Trouble is, if you use that feature, then you're tied to Kubernetes in all your environments. If you're using that feature of Kubernetes to have logging alongside your application container, then if your devs run just the application container, they've got no logs. So try and do this without taking a specific technology dependency. And then don't break the dev workflow. So this is really important. So breaking things into these side pod containers that you run alongside each other and sidecar containers in a pod, that's great, except when developers want to do Docker container up. You should be able to have run a container, start up your application without knowing that these bits need to all fit together. You shouldn't have to break the dev workflow. Okay, so on to the first one. So logging. All your legacy application platforms, I keep saying legacy, what I mean is the core business apps that actually make money for most companies. They all have their own ideas about logging, and mostly they're not about writing to the console. Especially in the first example I'm going to use is .NET, but the other example on GitHub is with Java, with Tomcat. I've got my processes running my actual application inside a Windows service. So it's in the background in the container. Docker knows nothing about that. Okay, so it's just running away here. It's got its own mechanism for making sure that thing stays alive that Docker doesn't know about. And it's writing logs to a file somewhere, or to the Windows event log, or to syslog. To get those out into Docker, what we need to do in this first pattern is we need to know exactly where the logs are being written. So we need to know what the log sync is and where it is. And then we need to package a little utility alongside our application. And that utility is just going to relay logs from the place where it knows they are into the console. And then the startup of your container will be that utility. So in your startup process, instead of running your process or starting a Windows process in the background, you're going to do that first, and then you're going to run this little log relay utility. And that will scrape up all the logs that you've got currently in your existing platform, in your existing application, and just push them back out. So now they're in the world of Docker, and you can do everything with them. Okay, demo. So it's mostly demos in this session, actually. So let me show you what I've got here. So I've got a couple of applications. I've got my .NET application. I am available for web design consultancy if you want to pay my rate. So it's just a really noddy application. What it does, it's got two features. It can write some logs, and it can make a call to a database. And I've got a Java version, which does pretty much exactly the same. There's some configuration in there. There's a few other bits that we'll use for the whole of the session. In my .NET application, so this is already containerized. It's already running in a container on Swarm on my cluster. If I click this button to write some logs, it's going to go and do its stuff, and it's going to report back to me, probably, if the network is healthy, and say, I've written some log entries. So that's all it does. So I click that button, it writes some log entries. Where does it write them? It writes them here, because this is where it's configured. So it writes them into a file on the C drive inside the container that Docker knows nothing about. So if I flip over to I'm running an old version of UCP, so that shouldn't be allowed. I've got a stack of stuff here. This is my production cluster where I run my blog. So I need to make sure I don't accidentally turn that off. So here's my .NET application. If I go and look at the containers, I've got one. I started it a little while ago. If I go and look at the logs, it's not going to show me any. Like, we can sit here for a long time. There aren't going to be any logs because Docker isn't watching the log file, and there's nothing about that log file. So the first pattern is to make it understand that. So in here in my source code, what I'm currently running is this Docker file. So it's pretty simple. For all of these demos, I'm not using a multi-stage build. I'm not compiling from source, deliberately because I want to be able to say I can do this without the original code. So I've got a zip file from a previous deployment back in 2008. That's what I'm using. So I've got a Docker file here that's built on Windows Server 2016. It's got ASP.NET 3.5, so it's got everything I need to run my app. And then I just copy in my zip file, and then I expand the archive, and then I set it up using PowerShell. That's all I do. So that's why I'm not getting any logs out, because my app is running in the background. It's right into this log file. Docker doesn't know about it. So version 1, I've extended my Docker file, and so I've just added this bit at the end. So I'm creating a volume for my logs. So the log directory will actually be in a Docker volume, and I can do something with that later. I'm also copying a PowerShell script, just an ordinary script file, and that's what I'm using as my entry point. So now when the container starts, it's going to run this script. And the script is the utility I talked about. I could build this as an actual complicated utility if I wanted to in .NET or whatever I'm using, but this is so simple I can do it just with a script. And there's a bash equivalent of this for Linux too. So all I do in this script is I start my worker process. That's the web server, the .NET web server, the Windows web server. And then I make a call to the local host. So this runs inside the container. So calling the local host is going to warm up my website for me, make sure the process is running, make sure everything's ready for me. And as part of that, it will write the first log entry, because that's what my application does. First time it gets a request, it's going to write an entry to the log. So now this log directory, this log path will exist. And the final thing that happens is I write this get content to the path where my log file is with that tail flag, which is just like doing a tail in Bash or in any sort of Linux. So it's just going to watch that file now and relay every time a line comes into the log file, it'll come back out into the console. So it's just surfacing those logs that are already there so that Docker can see them. So I'm going to deploy this using my stack file. So my version 1 is here. Let's just check I'm connected to my actual cluster. Yeah, there we go. Cool. So I'm going to do a Docker stack deploy. I'm deploying version 1, and all that version 1 does is it just changes the image tag. So I've already built all these images because, building in images, you get the idea with building images. So I've updated that to a new version. So now if I go back to my Docker Enterprise, my old release, this is going to show me that I've got a new container starting up and the old one will have died. So I'm going to go to Swarm, Services. Perhaps I should use my phone. Okay, cool. I should have carried on that Zoom call, and then we could have just had a chat with the family while we were waiting. Okay, so .NET FX Web. If I look at the containers here, I'll see a dead one that's just been replaced because that's part of my update. I've only got one container, so there wasn't a big rolling upgrade. It just did that one. So now I've got this container here now. So if I go back here and browse to my site again, so at the top there I've got a container ID. That changed because I've got a new container now. The configuration is still the same. So if I click write logs, this is going to do the same output. So the app is the same, the image, the actual code is the same. All that I'm doing now is I've got this little utility in there that's spitting out these logs. And now I can see these logs. So they're not particularly interesting, but they give different levels of logging, and they just repeat for a specified number of times. So Not very exciting, but unfortunately essential and quite easy to do. So it's something you need to put into pretty much all your Docker files when you start moving across these older applications. Okay, second one, config. So I said that you need to bear in mind that you need to be able to get configuration from your platform, from where you're running your containers, to make sure that you can use the same image everywhere. So that's really important because that is your binary guarantee that everything you're running in every environment is the same and it's passed all your checks. And if you're an enterprise customer and it's been signed and scanned and all that good stuff. And again, most legacy application platforms have their own ideas about configuration. Like they expect to find an XML file in a certain place, or JSON, or a properties file, or whatever. But they have their own expectations, and you need to match that so that you don't have to change code. So the pattern here is you're going to bake some default configuration in your image. And this is part of not breaking the developer workflow. All the slides will be available afterwards. You don't need to take photos. And I think they're recording this session too. So you have to have a default configuration in your image so that developers can do Docker container run and it'll just work. Now that default configuration should be your development config settings because you don't want to be baking your production passwords into your Docker image. So your default config should be there. And your configuration file should be at a known path. Again, I need to know that, where it's living inside the container, so that I can override it. And so what's going to happen is that when I run my container in the platform, I'm going to inject configuration that lives inside the platform into my container. And again, it doesn't matter what orchestrator you're using. Both Kubernetes and Docker Swarm have the notion of configuration objects, where you can load XML or JSON or text or whatever, and secrets, which are encrypted in Docker Swarm and not encrypted in Kubernetes, but hey, that's up to you. So the platform is going to inject the configuration into the container, and the app will just read from its ordinary configuration location. Okay. Demo for this. So I'm switching to Java here, so, keeping people interested. I last did Java when I did my computer science degree 20 years ago, so please don't comment on my code. So my Java application looks pretty much the same. I've got the ability to write some logs and the ability to execute some SQL. I've got two bits of configuration here. So firstly, where the log files get written, that's all coming from configuration. This is the log4j config that's baked into my image. So this is the default configuration. And then how many log entries to write, that's also baked into the image. So this is my app properties that are part of my default configuration. So I've already got this set up with my logging relay for my Java application. So when I click that and I go and look at my Java service, show you the Docker file while I'm waiting. So the Docker file for version 1, it's pretty simple. So I'm starting from Tomcat. I'm using Alpine, so I've got the slimmest version of what I need. It's a Java application that's originally designed to run on Tomcat. Again, it's just a zip file, and all I'm doing is setting up some bits and pieces. So I get rid of the default location for where Tomcat has its default websites. I copy in my website, and then I unzip it. Okay, so that's all it currently does at the moment. For version 2, I'm doing this configuration setup. So let me see if I've got this working right now. So here we are. So here's UCP. If I go and look at my Java application, how long have we got? So Java web, inspect resource, look at my containers. So if I look at the logs, that's why. So sometimes Tomcat has this really slow startup, and that's why we got that issue. Cool. Okay, we're going to replace that in a second, so that doesn't matter. Okay, so version 2, I'm doing a couple of extra things. So the first part is the same. So for each of these Docker files, I'm just additively adding on the patterns that I talk about. So I'm capturing a bunch of environment variables. So one of these is the application root, so I know where everything is. So in future, I can refer to that with an environment variable. And I'm also capturing the path to the configuration files. So my logging properties path and my web XML path. So what I currently package inside my application are the default values, which live inside the source code. So I've got the source here, even though I'm packaging up the zip file. And in here somewhere, I've got my web XML with this very friendly configuration format that's very easy to read. Somewhere down here, okay, so I've got this log count, which is an integer with a value of 5. That's the 5 that you see for how many logs to write. Okay, so now in my Docker Swarm, I've already deployed a secret. there's a configuration object, excuse me, a configuration object for my logging and for my property. So if I inspect that logging object, and you just do docker config create, similar API for Kubernetes, and you upload whatever you need. So this happens to be my log4j configuration, which is just text. So I've got all that set up, and I've also got a Java web, and I can see that too. And here's my thing. Now, this is my production environment. And I only want to write 3 logs here, so I can see this is the change. So this is completely separate configuration. I can put whatever I needed to in here. There's no secret information in here, so I'm using a config object so that I can see the values. If I wanted to keep it secret, I would use a secret, and then I wouldn't be able to see the data that's in there. Okay, so this is fine because this is just for config. So if I deploy a new version of this, which is using my version 2 image, and then while that's deploying, I'll show you how that config redirection actually happens. So inside my version 2 here, I capture these paths, and then I copy in this startup script, and I run the startup script when the application starts, okay? And what the startup script does is it looks to see if there have been any environment values specified for those path locations. So back in the Docker file, I initialize them as empty strings. So when I run this as a developer, they're empty strings. So when the script fires, it's going to see that they're empty and it won't do anything. But in production, when I'm running this in production, I will pass values here as environment variables, telling the container where to find the config for real. And then all that happens here is I do a link. I say, you're expecting to find your config file in /conf whatever, but actually redirect that using a symbolic link to the path that comes from my container platform. Exactly the same principle in Windows. So there's a PowerShell script with an alternative in Windows too. So that's all it does. It just redirects it. So when the application looks, it's still looking in the same place that it always was. But that content is now coming from whatever came from the container platform. And the way I make that happen is in my swarm file, in my compose file, I'm specifying these environment variables. So they're the ones that I'm overriding the defaults, which means the script will kick in and it will do the redirection. And where they're coming from are these configuration objects that live inside the cluster. So that's all I need to do. I need to make sure the config object lives in the cluster, and then I tell the container to load the content from there. Okay, so that hopefully has worked. So if I refresh this, so that's container ID A4. That should have been replaced. No, I don't want to do that. And I should find that the next container ID, there we are. So I've got a new container ID, and this content is now coming from the config object that lives inside my cluster. Again, it's pretty simple stuff. It's not complicated to do, but it is important so that you don't end up having a prod image and a test image and a dev image, because that kind of breaks the whole software supply chain. And I've also got different configuration in here. So I'm logging directly to the console handler because log4j enables me to do that. So I can write to Tomcat's console handler, and it will come, I get all the logs straight away. So now when I click on write logs, let's see if that's actually going to work. It's going to write some entries, and if I look at my service, where are my services here? I can check the containers. So that's the one that was killed during the replacement. This one's been up for a couple of minutes. If I look at the logs, so I get 3 instances of each of the logs that I'm writing. Okay, so I'm still getting my log output just from a configuration change here, and I'm configuring how the application actually behaves. Okay, so far so good. Let's go back here. Okay, so the third one is dependencies. So most of your legacy applications, they have this expectation of availability. So if I'm a web application and my job is to read data from the database and show it and then take input from the user and save it in the database, I'm not going to check the database is available every time I use it, because if it isn't available, I can't do anything. So why would I do that? Every single bit of data access code, I'd have to have all these checks. So they just assume that things are available. There's no error checking, there's no retries, nothing like that. And in the world of the data center, where my web server sat here, my database server sat here, it's probably okay to make that assumption. But in the world of cloud and containers and things dynamically spinning up and spinning down and moving around all the time, you can't make that assumption, because there will be transient failures. They will probably be transient, so a retry loop is probably all you need, but you can't go back and write a whole bunch of code to make that happen. So what you need to be able to do as a bare minimum is when your container starts, check that all the dependencies are available. So your app doesn't actually start up and look as if it's behaving correctly, but is unable to do anything, because that's what will happen. Your app will start without any dependency checks. The web application will sit there, but as soon as someone tries to use it, it will fail. So what this pattern looks like is you're going to bundle another utility with your container image, and this has got all the logic to check the dependencies exist before the application starts. So this happens after all the config redirection has happened. It's going to run before the application itself starts, and it's going to make sure that all the dependencies exist. Now, this is going to be a utility written in the same application platform as your actual application. And that's important because it can use the same configuration that your application uses that's being injected by the platform. Because there's no point injecting your configuration, your database connection string as a secret if your dependency check utility has it in plain text. So it needs to be able to do that. It needs to be robust because when this is going to run, it's going to report back and say whether the container is healthy or not, whether it's suitable to run. If the dependencies aren't available, the container is going to stop. And then the platform will know the container is stopped, and it will spin up a replacement. That replacement will run. It'll run the dependency check. Maybe the dependencies still aren't available because of an ordering issue, perhaps. Maybe this is a website and it's waiting for an API container to spin up. So that container will die, and then the platform will start up another one, and now the dependencies are there, so the dependency check passes, the application runs, and we know it works. So this is important in the world of being able to kind of dynamically have these applications without these hard-coded dependencies. So in Docker Compose, you can have this depends on flag to say that service A depends on service B. But that doesn't work in a stack when you're deploying to a swarm. And Kubernetes doesn't have anything like that. They used to have this notion of being able to declare that some pods had to start up before others. But if you do that, you kill the dynamism of your cluster. Like, it cannot do its job if you say that service A has to be up and running before you start service B, because service A could be 100 API containers running on my cluster of 20 servers. And service B could be 50 web containers running on my cluster. What's it going to do? Make sure all 100 API containers are started first? If one of my 100 API containers goes down, is it going to restart all my 50 web containers? You can't do that. You need your application containers to be able to check if everything's good for them to go, and if not, they just stop gracefully, and then they get replaced. Okay, so demo. So this one, this is a .NET one, isn't it, I think? Yeah, this is a .NET one. So what I've got here, I've got a dependency check utility. So let's show you what that looks like. No, actually, I'll show you the Docker file first. We're on version 3, of course. So the Docker file for my Windows application, so I've been going up in steps. So I showed you the Java one previously, but I've got the same stuff in my .NET one. So I've got these configuration paths that I capture as environment variables. I've got a little script in there which will do the symbolic link to redirect them if I need to. What I've got also in here is this dependency checker application, which is just a .NET console app that I package again as a zip file. So I'm following the same patterns of what I'm currently doing. And then I copy it into my image last of all, and I unzip it. Now, in my startup script, I do a couple of things here. So I've got this same thing to create the symbolic links for the config files. So that works in the same way. So that's happening. But what happens first of all is it does the redirections. Then it checks to see if the dependency check is enabled. And by default, it's set to off in the Docker file. So the dependency check is set to 0 inside the Docker file by default. Don't break the developer workflow. Like if I'm a developer that's working on the API and I don't care if some other dependency exists because I'm only working on one feature, I don't want to start my container and have it die. So by default, it's turned off. So I'm going to turn this on in my Compose file or my Kubernetes manifest. So if it's enabled, I'm going to write some logs, I'm going to run the dependency check, and if the exit code is anything other than 0, I'm going to return a 1. And so to Docker, the container's started, the process that it's running is this, and the process has ended. So that's it, container's dead. And then in a production platform, it would die and a new one would start up. And then the rest of it is the same. It starts the web process, and then it tails the logs. So we can see that in action. So here is my .NET application. So it's got this ability to be able to execute some SQL. If I click on this button, this is before the dependency check. So the app is running. Like Docker thinks everything's fine. If I've done a quick smoke test, I think everything's fine. But actually, eventually, this will realize that it can't reach the SQL database that it's trying to connect to, and I'll get a big yellow error screen, which if you work in the .NET world is something you're very familiar with. So this is, I don't know what this is, but actually I do know because there is no database. So what I'm going to do is the next version of my image is packaged with this dependency check utility. And that dependency checker is pretty straightforward. Again, there's a Java version of all these utilities as well. So the dependency checker, what it does is it just uses a package, a community package, to do some retry policies. So all it does is it tries to connect to the same SQL database that the app will use, but it does it with this little retry loop. So because I'm using a .NET application, I can use all my existing config and whatever logic I need to do, as complicated as it needs to be. Like, it doesn't really matter if this thing takes 2 seconds to run, because it's only going to run once at startup. So I make sure all my dependencies exist. I can write whatever nice friendly logic in here that I want without changing my existing application. Ideally, this would be in my app, right? This would be in the startup of my application. But if it's a 10-year-old app and I don't have the code, I don't have that luxury. I can package it as a utility. Okay, so I need to do my deployment. So let me deploy version 3. No way, that's wrong. Actually, I think we're fine. So I'll deploy version 3, and then we'll have a quick look at that stack file. So my version 3. So in here, I've got, so this is for my production deployment that's running in the background now. I've got my dependency check turned on. So this will execute, and as a developer, I wouldn't have that stuff. And I'm specifying to get all my configs and all my connection string for my database is all coming from the cluster. So just like with the Java example, the connection strings come from configs, but the config objects come from configs, but the connection string comes from a secret. So that's encrypted in the cluster. So the way Docker Swarm works is if you save a secret in the cluster, it gets encrypted in the database that the nodes use. It only gets delivered to a node if that node is going to run a container that needs that secret, and it only gets decrypted inside the container. So the only way I can see that secret's content as plain text is if I'm inside a container that's got authorization to use that secret. Okay, so that's been deploying. Let's go back and reload this. And I will look at the log entries for my service. Where are you? So I've got a bunch of containers now that have been replaced from my various deployments. If I look at the log here, oh yeah, I should have said, the other thing I've got here is I'm running a SQL Server database as well. So the dependency will exist this time. So what I will see, so I will see in this one, if I look at the logs here, okay, let's try again. I need time added on for the network issues. Okay, so Swarm services. Either that or I need a bigger laptop with 32 gig of RAM so I can run everything locally. So services. It's worth the wait, I promise you that. So here we go, NetFX, containers. Okay, cool. So here's one that's been up about a minute. Look at the logs. And I will see some new log entries in here. So I see the stuff about doing the symlinks for the config files. And then I see that it's validating the dependencies and the dependency is OK. So what actually happened there, the reason I've got another dead container is that container started before the SQL Server container was ready. So it did the dependency check and it failed. And then it died. And Docker just started a replacement. And by the time this one started, the dependencies were available. So everything's good to go now. So let's get rid of this and go back here. Now if I click this button, look at that. It gets the date and time from the database. So the dependency is there, but the app wouldn't be running if it hadn't been able to get to its dependency. So that's a nice little thing you need to put into your Docker files to make them robust. Okay, the fourth one is health. So this is kind of, the dependency check is at startup. You do that once. The health check is something you run repeatedly. So it's telling the container platform that your app is actually healthy. So Docker has this kind of rudimentary way of doing checks. It will check that the process that starts your application is still running, and then it will say the container is running. If that process dies, then it says the container is dead, and then it will do whatever evasive action it needs to do. So in our case now, because we're running all these utilities, this log relay and this other stuff, the process that's running isn't our application process, which it wouldn't be anyway. Like in the Windows example, it would be this process that's buried somewhere in the stack that Docker knows nothing about. So checking that the process is still there is not a very good check. And even if it was my web application process that Docker was testing, the fact that the process is alive doesn't mean my application's healthy. So if it was a Go application and the process is still running, but it's a web server and it's completely maxed out, the process is still there, but it's going to return a 503 to every request. So the health check is a much nicer way of proving that your application is actually healthy. And again, there are different ways of doing this in Swarm and Kubernetes, so it's important to make your solution to this transferable. So my suggestion for this is to have a health check utility. Again, have a utility that's written in the same application platform as your actual application. Not just because you can use whatever logic you currently use and you can exercise whatever you need to do and be comfortable with your existing platform, but also because you're reducing the amount of dependencies you have. So if you're using curl to do a simple health check, then you need curl. Now, if you've got a tiny Go application built on top of an Alpine image, adding curl will triple the size of your image and add all this surface area. That means actually you're probably updating your image to do a curl update more frequently than you are to do an application update. So if you've got a Go application, write your health check in Go, and then you've got no extra dependencies to take into your image. So I'm going to bundle this health check utility. I'm going to run it periodically. How you run it depends on your orchestrator, but it doesn't matter because all the logic is inside this utility. And it's going to exercise as much of the app logic as you need to prove that your app is really healthy. So if it's a web app, it's going to call localhost. It's going to do get to localhost, make sure I get a 200, and then maybe I want to make sure I get a response within 200 milliseconds. Or maybe I'm going to exercise a certain path through my logic to prove that I can get to the database and I can get to the APIs. It needs to be robust enough that when it runs and it says it's healthy, you're definite that your application is healthy, but it also needs to be fast enough so you can run it every 2 seconds without hammering your container CPU. Okay, so demo for this one. Which one am I doing? Java. Okay, so Java for this one. So my Java health check, again, it's a little utility written in Java, so I don't have any extra dependencies. And all it does, source, com, Docker samples, main Java. It imports a few useful packages to do some stuff for me. And it's doing exactly what I mentioned there. It's going to do a get to the local host, and it's going to make sure that I get a response within 150 milliseconds. So I write out some logs so I can see what's happening. So I don't just want to prove that my app is running. I want to prove that I should get the home page from localhost within 150 milliseconds. And if I don't, then my exit code is 0. And that's it. That's all I need to do. So this is going to run periodically. So inside my Docker file for version 4, I've got all this other stuff from the previous ones. I've got my dependency check, the equivalent of the .NET one. I'm copying in this jar file for my health checker, and then I'm specifying inside my Docker file that this is going to run every 2 seconds. So I'm going to run Java, I'm going to run my health checker. This is where it's different from Kubernetes. So in your Docker file, you can put a health check, and Docker Swarm, if it sees a health check inside the image, it will honor it, and it will execute that health check for you. In Kubernetes, it ignores the health check in the image, and you specify in your kube manifest what this should be, what your health check should be. But because it's all the logic, all the clever stuff is inside that jar file, it doesn't matter how you invoke it. You're going to get the benefits from it. Okay, so let's deploy this, and then I'll show you how it looks. This is a particularly nasty demo. So I didn't really focus on this, but I'll show you how this works. If I run this, switch back to my Java file. So you see sometimes in the top there, it says slow mode. So this application has got some logic in it. So periodically, it takes more than 200 milliseconds to return. It's just a random thing, and every now and then it will go slow. So that will trigger a failure of the health check, which makes it a very difficult demo to do, because sometimes it will fail and it will replace itself, and sometimes it won't. So I will probably skip over that bit. But let me show you how it actually works. So the Docker stack file for here, I've got my dependency here. I'm using MySQL for the Java app. I've got version 4, which has the health checker inside there. And although the Docker image has a health check built in, just like Kubernetes, in my compose file, I can specify the health check to be slightly different. So I'm saying I don't want any retries, so run the health check. The default is 3 retries. 3 failures in a row means the container's unhealthy. By default, I'm overriding that, so if it fails once, then we're gonna restart the container. The interval is 20 seconds, so run it every 20 seconds. But because I know my app takes a long time to start up, I don't want it to fail within the first minute and a half in this case. So for a minute and a half, if the health check fails, Docker's not going to do anything. And then with every 20 seconds after that, if it does fail, it will get replaced. So if I refresh this, no, not that, this. Okay, so I need someone to remember that ID, or just the first bit. So it's E3. I'm going to move on to the next demo, because actually this will take a while to actually fail. And when we come back to it, this will be replaced by a different container by Docker without me doing anything. So what I get by adding this pattern to my image is I get a self-healing application, like Netflix have, but for my 10-year-old Java app. So I get all that great stuff without having to do a whole bunch of work. OK, so let's go back to my slides here. So the last one is metrics. The last one is metrics. So I've got all this great stuff running, and actually most of my legacy applications already do this stuff. Like they already have ideas about logs and config and everything. They're already collecting metrics for me. So a Windows application in a Windows container is still collecting Windows performance counters. They're still there for IIS and .NET and all that stuff. My Java application in my Tomcat container, Tomcat keeps all these metrics for me. All I need to do is be able to make them available from my container. So the final pattern is about exporting the metrics that are already there, that your application runtime is already collecting for you. So it's another little utility that you're going to package with your app. It's going to run in the background, and it's just going to add an extra endpoint to your container, which you're going to use internally within the cluster. So it'll have a /metrics endpoint now that you can use to go and talk to it. And it's going to expose those metrics that already exist. Now, again, there are the way that I'm doing this is with Prometheus, because the Prometheus metrics format is pretty much the standard one, and it's the one that Docker uses, the Docker engine itself. So my little export utility, I'm not going to go into detail on this one, but again, it's all on GitHub, so you can see it. The final version of my .NET Docker file, it has all the stuff we previously talked about, and then it also has this little exporter utility that I'm copying from a different image. So if you're not familiar with multi-stage builds, what I'm doing here is I'm referring to yet another image that lives on Docker Hub that's got this monitoring exporter, and I'm copying that straight into my application here. Same with Java, there is a Tomcat exporter for Prometheus, like a community one. You just bundle it straight into your application, and it just works. This is a sample application for .NET ones. So, and in here, in my startup, the one new bit is that I start my process, I make my request, and before I do the logs, I start my metrics exporter. So now my application, when it's running the application itself in the background, it's running the log relay in the foreground, and it's running the metrics exporter in the background too. So my container is doing lots of things now, which again is not what you classically expect from a container, but you have to do that if you want to bring every app into the modern world. Okay, so final deployment. I think I've got loads of time left, haven't I? Great. So let's do this. I'm going to deploy version 5. And all I did with version 5 in my stack file is I'm using the latest version of the build, which is here. I'm still publishing to the same port. I've got my health check and all that stuff. I'm also running Prometheus. So I'm running Prometheus, although this is a Windows container, I've got a hybrid cluster with some Linux and some Windows nodes, and I'm running Prometheus in a Linux container, so I can use the official Prometheus image. So Prometheus will go and read the metrics from my Windows container. It's just going to use DNS. It will just find it by the container name, same as everything else. So the fact they're on different servers makes no difference at all. OK, so that's going to have been deployed. So let me see if this is up and running. And I promise we're nearly done. So this is up and running. Who can remember the Java container ID? Ended? No, you've got to do what it starts with. It started with E3. So if I refresh this, let's see. OK, so that's been automatically replaced for me, right? So it failed, Docker replaced it, everything's great. Didn't even have to go and check it. OK, so this one's up and running, so that's cool. So if I send some requests in here, this is just going to generate a little bit of load. It's going to start recording those metrics that Windows already records for me. And now if I go and browse to my Prometheus that's running in a container on the same cluster. I'll leave the most dangerous demo for last. So my configuration for Prometheus is being loaded from the cluster. So I'm using the standard Prometheus image. I'm loading a config object in. It's telling it to go and check my .NET application container. And as long as the health check hasn't kicked in, I should find that it's up. So that's cool. So I can go to the graph. If you haven't seen Prometheus, this is just standard Prometheus, which is a metrics server, grabs metrics from your containers, and lets you run a dashboard so you can see what's going on. So if I go and look here at requests per second from my website, and I look at the graph, and I zoom this out, you can see there are a few requests coming in from when I did my refreshes. So I'm getting all this stuff for free, all from just by packaging it in my Docker file. Okay, so I haven't finished yet. So the last thing is, and I touched on this very, very briefly. So I'm running a hybrid cluster. I'm running Docker Enterprise, but you can do this with standard Swarm. And as of maybe April next year, if you're lucky, you'll be able to have a hybrid Kubernetes cluster too. So I'm running, I've gone too far away. So I'm running Swarm and Kubernetes here, and you could, if you wanted to, have different teams deploying to different things. So like I have my Prometheus running in a Linux container, talking to my .NET Windows container on a Windows server, it all just works. And I can have one cluster where I'm running all my stuff. And because I've packaged up my legacy apps so they behave like modern apps, I'm going to build, manage, deploy, and work with everything in exactly the same way. Okay, this is the one to take a photo of. So if you're interested in what you can do with EE, then you can go to that, get a trial. There are a bunch of videos about taking old applications and migrating them. There's a .NET version and a Java version. If you want to see today's demos, they're all up on GitHub. There's a short link. I'm on Twitter at Elton Stoneman. If you've got any questions and you don't find me this week, I'm just elton@docker.com. Feel free to email me. I have to reply because that's my job. If you want to leave a review, I would appreciate that very much. Thank you for singing at the beginning. And don't forget, Windows is going out of support soon, so we can help you with that. Thank you for listening. Sorry I went over time. I hope you enjoy the rest of DockerCon. It's the best conference there is. Thank you. Okay.